So hi folks, welcome to Neural Nexus. So in this video, I'll be explaining how my MS seminar has been done. So I'll be giving you all the technical details of it. So this is Rajaram. So my GTC members are Dr. Prakash Sai, Dr. Nargis Parvin, Dr. Rupashri Barrel, Dr. Soman Sarkar. So the title of my research topic is Enhancing Scalability through Lottery Ticket Hypothesis and Knowledge Distillation Based Neural Network Pruning. So we will quickly see about the introduction and the motivation, about the problem statement, about the research background, then the baselines and its implementation, then the models and the methodology which I have used, then about the results and its implications. So let's dive in. So I hope all of you are aware of what IoT is, right? Internet of Things. So compared with just few years ago, we are living in a very different kind of era where there are millions and millions of IoT devices which are operating across our globe. So right from a smart car to a smart fridge, everything is being linked with the cloud and is trying to be more smarter. So IoT has the power to change the society for the better by interlinking all these devices and all these information onto the cloud. So when there is a huge amount of IoT devices which is operating across our globe, there are 6 major problems which has to be which has to be addressed. So the first one is vast amount of data. Second one is latency in data transmission and processing. Third one is the privacy risks. Fourth one is security maintenance. Fifth one, which is the current industry problem which all the companies are actually facing, which is high electric power consumption. And the last but not the least is service continuity. So if we were to say that data storage company is emitting an equal amount of carbon footprints as an automobile industry, so can you ever imagine it? But that's the bitter truth which we have to digest. So from all these problem statements which we have actually discussed, we have to try to give a solution. That is, we have to try to give a sustainable solution which imparts social value to the society. So if we try to decrease the amount of data transfer to the cloud, we can be able to decrease the power consumed by all these IoT devices. So the figure on the right shows if you just see here, those thick lines represent a huge chunk of data which is being transmitted from the edge device to the cloud, whereas the figure on the left, the figure on the right represent very thin line if you see. So those thin lines represent a very small amount of data which is being transferred onto the cloud. So this introduces to the concept of edge computing, where a huge chunk of data which is getting transmitted, that is huge chunk of unwanted data which is getting transmitted, are actually cut down on the edge device itself by using an extra artificial intelligence layer. So this introduces to the concept of edge computing. If we actually talk about one of the potential use cases in terms of scalability and power consumption is to handle a vast amount of user traffic for product or for any movie based recommendation systems. So also nowadays there are so many smart cameras which are actually being manufactured, which could be placed in shopping center, which could be placed in bus stand, and which could also be placed in the parking slots to make the city more smarter. So all these are the potential use cases of it. So after doing a vast literature review and after discussing all these problem statements, we have found 2 major research gaps. One is the scalability issue in recommender systems, and the second one is the power consumption, which is a very major constraint which leads to the increased cost. So drawing my problem statement which I solved during my MS tenure is just putting the problem statement into very simple words. The problem statement is to develop a novel deep learning model which increases the scalability and decreases the power consumption on any edge device, which does in the recommender systems or image classification part. So this is my actual problem statement. So talking about my baselines, there are 5 major baselines. One is paying more attention to attention. Second is movie rating on the prediction. Third one is show, attend and on the distill. Fourth one is contrastive representation distillation. Fifth one is learning what and where to transfer. So these are my 5 baselines which my model has actually beaten. So talking about